Okay, the next rule, the next division rule that I am going to talk about is constraint egalitarian rule. In short, I use the notation CE. Again, rather than R, I'm going to use CE. Well, this is how we formally define it. It's kind of a step function. So for any claims problem, CE, and for any player I, or the agent I's reward is equal to the minimum of half of his claim, or lambda, if the surplus is less than sum of half the claims. However, if the surplus is greater than sum of half the claims, well then each player I's surplus is equal to the max of player I's half surplus, half claim, or minimum of his claim and lambda, the same lambda, where the lambda is calculated so that when we sum up all the players' awards, we get exactly E. So the outcome or the reward is efficient. Okay? Well, by definition, this is clearly this rule satisfies non-negativity. It clearly satisfies claims boundedness, though the maximum value that the CI can take is, the claim itself, CI. Obviously it will never be equal to more than CI and less than 0. And because efficiency holds right here, feasibility will also hold. What about the other? Well, the others, I think, once again, the equal treatment of equals is pretty straightforward. Lambda is same across players, and if two player has exactly the same claim, they should be rewarded equally. All right, and the others are, again, it's not so difficult. You can check them. I leave them in an exercise. I will go over some of them in the review session. But again, this rule satisfies all these properties. Well, intuitively, it basically says the following. So let's look at the claim vector and sort of look at or concentrate on the half of the claims. All right. Well, if still even the half of the claims exceeds the sum of the half of the claims exceeds the initial surplus we want to distribute, well then, you know what? We try to basically distribute at most half the surplus. So apparently some agents have very large, some creditors have very large claims, right? Maybe all of them, but some of them has definitely very large claims. And so we clearly cannot fulfill all of them. So what we do, we try to give at least half of each individual's claim. Obviously, we don't give half to everyone. There's this lambda. Remember, we are choosing the minimum of. If CI is still too large, maybe we're going to give him lambda. So again, out of all the big creditors with big claims, I'm going to give either lambda, all of them, at most their half claims. All right? Well, what else? Well, remember in the previous one, we were giving them their claims exactly, but this time we're giving half the claims. Well, however, if the claims, the sum of the half of the claims is not too big, so it is less than E, well then we're going to give them at least their half surplus claims, and so it's going to be determined according to this. All right, well, let's look at one simple example. The surplus to be distributed is 200, and the claim vector I'm going to be working on, the same ones, 100, 0, 200, 0. Okay, well, when you look at this Cj divided by 2 summation, what do we get? Well, I have 50 plus 0 plus 100, right? I'm just taking the half of all the claims and add them up, 50. So this is equal to 200, which is exactly equal to E. So therefore, we basically satisfy this, all right? Well, then what do we have? Well, we have therefore the constraint egalitarian rule. Reward is going to be equal to, I ignore the CE in the parentheses, the minimum of the first player's claim. I don't know what lambda is, so I'm going to calculate lambda as I did previously. So half of his first player's claim, which is 50, comma lambda, and then minimum 0 lambda, and then minimum half of 200, which is 100, comma lambda, and finally minimum 50 lambda. Okay, so once again, we need to look at the sort of values of lambda, where lambda is less than or equal to 50 and greater than or equal to 0, and lambda strictly greater than 50 but strictly less than or equal to 100, and lambda greater than 100. Okay, well, obviously you can look at cases where lambda is less than 0 but don't, because lambda will never be negative, obviously. Okay, I mean, it may not be obvious, but if you look at those parameters, you'll see that lambda can never be negative. Okay, so I have, if this case, lambda in between 0 and 50, well then this term is equal to lambda. Okay, so I'm adding up and check if is going to be satisfied for some lambda value in between 0 and 50. This is what I'm trying to do. Here it's going to be 0. Here the minimum is going to be lambda. Here the minimum is going to be lambda. So basically 3 lambda equals 200. That means lambda equals 200 divided by 3 once again. But I know that this is greater than 50. So you know what? This case is not going to give me some lambda. Well, if lambda is greater than, well, I found lambda here, so it is in this region. So does that mean that lambda is 200 divided by 3? No. Well, maybe it is, okay? But you have to write down this summation under this assumption and then see if really lambda, which is equal to 200 divided by 3, is in this range. You see what I mean? I mean, after finding lambda for this case, you cannot say, well, it is in this case, so therefore I can use it. No, you can't do that, right? So under this assumption, the CE, the constraint egalitarian rules reward vector becomes, remember this is minimum of 50 and lambda is greater than 50. So this becomes 50. All right, so 50 plus, this becomes 0. This becomes, its lambda is less than 100, so lambda. So this becomes 50. Is this equal to 200 for what values of lambda? Well, 50 plus 50, 100. If I send 100 to the other side, 100, so lambda is equal to 100. Okay, so you know what? That's it. Lambda is definitely in this range, and so I just found the value of lambda which will satisfy this. Well, you can check this case. What if lambda greater than 100? I mean, you may be suspicious. Fine, let's do that. So if lambda is greater than 100, this min still 50. This is still 0. Oh, sorry, this is plus. I'm sorry about my terrible notation. So this guy is going to be 100, okay? And finally, this guy is 50. Well, what do I have? I have 200. Well, yes, 200 equals 200. Good. But what is lambda? Well, there's no lambda. Lambda basically vanishes. Well, this 200 equals 200 holds simply because the summation of half the claims was equal to E. And so I didn't really need a lambda value. So therefore, as you see, I found only one lambda value, which is 100. So therefore, in this problem, in this specific problem, all right, lambda must be 100. What does that mean? That means, remember, we had this case. The E was equal to this case. So therefore, the reward vector for, well, let's forget about I. So the reward vector for this problem is going to be the minimum of Ci divided by 2 comma lambda. So lambda is 100, so don't forget that. So Ci over 2, 50 for player 1. Which one is minimum, smaller, 50 or 100? 50 obviously. 0 or 100? 0. 100 or 100, doesn't matter, 100. And then 50 or 100, 50. So therefore, according to constrained egalitarian rule, in this problem, the reward vector is going to be this one. Okay, so this is how we calculate a constrained egalitarian rule. I hope that was clear.